In this video, I will walk you through free response question number 1 from the 2018 AP Calculus exam. This problem is an accumulation problem involving an escalator, so we will be working with integrals. This is a calculator active problem, so we will be using our graphing calculator to the fullest extent. People enter a line for an escalator at a rate modeled by the function r given by this, where r at t is measured in people per second and t is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second. There are 20 people in line at time t equals 0. Part A. How many people enter the line for the escalator during the time interval from 0 to 300? We have learned that the integral of a rate from A to B gives you the net change in amount from A to B. And that's exactly what they are asking us to find. When they say how many people enter the line between 0 and 300 seconds, they're asking us for the net change in the amount of people between 0 and 300. So to find this, we need to find the integral of the rate of change of people. And that's exactly what r at t is. R at t, measured in peoples per second, is the rate of change of people entering the line. So we just need to calculate the integral of r of t from 0 to 300 to find out how many people entered the line between time 0 and 300 seconds. This will be easy to do because this is a calculator active problem. So let's hit y equals and type r of t in for y1. R of t equals 44 times t divided by 100 to the third power times 1 minus t divided by 300 to the seventh power. So we can just type all of that in like so. I'm using the x variable instead of t. Now we just need to evaluate the definite integral from 0 to 300. So back to the calculator. Let's quit our way out of this by hitting second quit. For the integral, we hit the math button and choose option 9. We are integrating from 0 to 300. And we want to integrate r of t. But remember, we typed r of t into y1. So we just need to get y1 in here. We do that by hitting the vars button, which stands for variables, switch over to the y variables tab, and just choose option number 1 for functions. And there's y1, just hit enter. So here we are integrating y1, which is really r of t. And put your dx on the end. And that's it. So 270 is the answer. Since this is the AP exam, let's write our answer as a sentence. 270 people enter the line during the time interval from 0 to 300. Part B. During the time interval from 0 to 300, there are always people in line for the escalator. How many people are in line at time t equals 300? Remember that in the setup of the problem, they gave us two different rates. They gave us a function for the rate at which people enter the line, and then they gave us a constant function for the rate at which people leave the line. The overall rate of change of the people in line will equal the rate in minus the rate out. The rate at which people enter the line is given by r at t. The rate at which people exit the line is a constant 0.7 people per second. The first fundamental theorem of calculus tells us that the end amount at b equals the initial amount at a plus the integral of the rate from a to b. In the context of this problem, the end amount will be the number of people in line at time t equals 300, and the initial amount will be the number of people in line at time t equals 0. The integral of the rate from a to b will be the integral from 0 to 300 of the overall rate of change of the people in line, which we just decided was r at t minus 0.7. In the setup of the problem, we were told that there are 20 people in line at time t equals 0. So the initial number of people in line is 20. This is a calculator active problem, so we can type this entire thing into the calculator. We start out by typing 20 plus. Now it's time for the integral. We hit the math button and choose option 9. We are integrating from 0 to 300, and we are integrating r at t minus 0.7. Remember that we typed r of t into y1 under the y equals button. So we don't need to type it in again. We can just hit vars and switch to y vars and choose option 1 for function and choose y1. So y1 is really r of t. And then we subtract 0.7. And we will put dx instead of dt. And that's it. Kabam! 80 people. There are 80 people in line at time t equals 300. Part C. For t greater than 300, what is the first time t that there are no people in line for the escalator? In Part B, we just found that there are 80 people in line at time t equals 300. According to the piecewise function in the setup, for t greater than 300, r at t is 0. In other words, for times greater than 300 seconds, no one is entering the line. That means the only change will be that people exit the line at the constant rate of 0.7 people per second. So for this time interval, the rate of change of people in line is simply equal to negative 0.7 people per second. Here comes the first fundamental theorem of calculus again. The end amount at b equals the initial amount at a plus the integral of the rate from a to b. Since we are looking for the time that there are no people in line for the escalator, the end amount that we are looking for is 0 people. So we will use 0 for the end amount. We know that there are 80 people in line at time t equals 300. So let's use 80 as the initial amount. Now, how about this integral? I'm going to integrate the rate, which is negative 0.7, a very simple function. But I'm going to integrate it from where to where. Our initial amount of 80 people is at time t equals 300. So that's going to be the start time. What about the end time? The end time is what we're looking for, the time when there will be 0 people. That's an unknown time, so let's just call it t equals x. So let's just put in x for the upper limit of integration. So what we have is an integral defined function. This is not a problem. We can just graph the right side of the equation and see where it equals 0. So let's type all of this as a function into our graphing calculator under y equals. So let's move down to y2, and we are going to type 80 plus this integral. So let's go 80 plus. For the integral, we do math 9, and we are integrating from 300 to x. So 300 to x. All right, it's an integral defined function, but your calculator can handle this. And in here, we have the simple function of negative 0.7. And we can just use x again, and that's fine. So let's graph this. Right now, we have 2 functions highlighted. We only want to graph the second one. So I'm going to come back here and get on the equal sign of y1 and hit enter. So I'm turning this off. So when I hit graph, I will only be graphing the second function. Before we hit graph, we should think about the window that we need to view this graph. The x values start at 300. We're talking about values that are greater than 300. So let's click on the window button, and for the x max, this is going to be bigger than 300. So we need to pick a number like 400, 500. Let's just pick 500. We can always adjust this later. For x min, remember, we are staying bigger than 300. So we might as well just type in 300 for x min. What about the y values? Well, we are starting with a maximum of 80 people, and then it's decreasing and decreasing all the way down to 0. So for the y max, let's choose something bigger than 80. Maybe I'll just do 100. And we're going all the way down to 0, but let's leave a little space. Let's leave it at -10. So let's hit graph and see what we get. This red line represents the total number of people over time, and we want to find the time when the number of people is 0. There is a function for that, so we can just hit second trace, and we will choose 0. The calculator is asking for left bound, so just make sure that you are a little bit to the left of the x-intercept and hit enter. Now the calculator asks for a right bound. Move the pointer to the right of the x-intercept and hit enter. When the calculator asks for a guess, move the pointer right to about where you see the x-intercept, as close as you can, and hit enter. So this is the answer, 414.286 seconds. On the AP exam, they will accept 414.286 if you want to round, because the next number is a 7, or they will accept 414.285 if you just want to truncate and cut it off. The first time there are no people in line is at t equals 414.286. If you don't like graphing, perhaps you're uncomfortable adjusting the window and all that, you can solve this problem without graphing. We can simply treat this integral like a definite integral. So we would have 0 equals 80 plus, and to evaluate a definite integral, you find the antiderivative, which in this case would be negative 0.7 t, and then you evaluate that antiderivative using the limits of integration. So we will evaluate from 300 to x. And then, in order to do this, we find the value at the upper limit minus the value at the lower limit. So we would have 0 equals 80 plus. So here comes the value at the upper limit, which is x. So we will have negative 0.7x, and then minus the value at the lower limit. So that's going to be negative 0.7 times 300. So then we just have 0 equals 80 minus 0.7x. Minus a negative is addition. 0.7 times 300 is 210. Adding 80 plus 210, we get 290 minus 0.7x, all equal to 0. Adding 0.7x to both sides, we get 0.7x is equal to 290. Dividing both sides by 0.7, let's see, 290 divided by 0.7, we get 414.286, which is the same answer that we got the last time. Part D. For the closed interval from 0 to 300, at what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time. Justify your answer. In other words, they are asking us to find the absolute minimum on this closed interval, so we're going to need a candidates test. The first step of creating a candidates test is to find the critical values. If we had a function f for the number of people in line, to find the critical values, we would set f prime equal to 0. However, we don't have a function f representing the number of people in line. So instead, we will think of it as setting the rate of change equal to 0. This rate is the rate of change of the number of people in line. For a rate in, rate out problem, the overall rate of change is the rate in minus the rate out. So this is what we will set equal to 0. But in the setup, we are told that the rate in is given by the function r of t. And the rate out is a constant 0.7 people per second. So this is what we will set equal to 0. It will be a little bit easier to find the values of t that satisfy this equation if we add 0.7 to both sides. So we need to find at what times t, r of t, is equal to 0.7. In other words, for what values of t will the rate in equal the rate out? Let's use the graphing calculator to find these values of t. Hit the y equals button. Make sure you have the rate in function typed in as y1 and the constant rate out of 0.7 typed in as y2. We want to find where the rate in equals the rate out, and we're going to use the graph to do that. However, before you hit that graph button, let's adjust the window. So hit the window button. Right now we have a default window of -10 to +10 for xmin and xmax. What kind of adjustments do we need to make? Let's start with the given interval. We are looking at only values of t between 0 and 300. That's your xmin and your xmax. So let's make that adjustment. The xmin must be 0 and the xmax will be 300. Now the ymin and the ymax takes a little bit more thought. The main thing I'm looking at is the fact that the constant rate out is -0.7. That's a pretty small number. So in general, we are talking about small numbers probably for the rate in and the rate out. So we might make the ymax be something small like 1, 2, 3, or 4. We can always adjust this later, but I think I'll go with, let's say, 3. For the ymin, again, -10 is very big, and we know these rates are not going to be negative. So I think I'll just make it -1. I always like to see a little bit below the x-axis so I can clearly see what's going on. Let's go ahead and hit graph right now and see what we've got so far. Ooh, that is a very nice looking graph. So we are looking for these 2 points of intersection. So hit second trace, and option 5 is for intersection. Move your pointer close to the first point of intersection and hit enter 3 times. Enter, enter, enter. So this is our first critical value, 33.013. I would like to store this into a letter for future use. So hit second quit, hit the X button, hit the store button, and I'm going to store this value into the letter A. So alpha A, enter. When I need to use this number later, I can now just type A instead of typing all of these decimals. To be clear, if you don't use this shortcut, if you need this number again later, you're not allowed to just type in 33.013. You have to use all the decimals that you see here. Let's go back to that graph, and find the second point of intersection. So second trace, intersect. Now move the pointer close to the second point of intersection and hit enter 3 times. Enter, enter, enter. This is the second critical number. Again, second quit, let's store that number into a letter. So hit X and the store button, and I will store this value into letter B. So alpha B, enter. So we have our 2 critical values. For the candidates test, we need to find the number of people in line at the endpoint times 0 and 300, and the number of people in line at the critical value times that we just found. In the setup of the problem, we are told that there are 20 people in line at time t equals 0. So the first value is given. The number of people in line at 33.013 seconds will be the initial number of people plus the number of people who entered the line by this time minus the number of people who have left the line by this time. The initial number of people in line is 20. We know that the integral of a rate is an amount, so the number of people who enter the line will be the integral of the rate at which people enter the line, so the integral of r of t. This expression represents the number of people who entered the line from 0 seconds to 33.013 seconds. Similarly, the number of people who left the line will be the integral of the rate out, so the integral of 0.7. This expression represents the number of people who left the line from 0 seconds to 33.013 seconds. Because the limits of integration are identical, we can write this as a single integral. We can type this expression into our calculator. Just remember that 33.013 is A, and r of t is y1. So let's type 20 plus. For integral, we do math 9. We want to integrate from 0 to a, so alpha a. And then for the rate in, that's y1. We will type vars, y-vars, enter, and just hit enter for y1. We could do minus y2, but it's even simpler just to type 0.7. And that's it. 3.803. We were asked to round to the nearest whole person, so we will just put 4. Similarly, the number of people in line at 166.575 seconds will be given by this expression. Just remember that 166.575 is the value b. So back to the calculator. I could type in this expression again, replacing a with b, or small shortcut, if I come up to this expression and hit enter, all I have to do is go over to where a is and type b instead. So alpha b and enter. 158.070. That rounds to 158 people. Finally, the number of people in line at 300 seconds will be given by this expression, so we just need to change the b to a 300. Again, to save time, I will just go back to the expression I typed in, and I will simply navigate over to the b and replace it with 300. Kabam! 80 people. Remember, we are looking for the minimum number of people in line and the time when that occurs. And we find it right here. The minimum number of people in line occurs at t equals 33.013 seconds when there are 4 people in line. See Candidates Test.